All right, so I think it's about 9 o'clock, so we'll get started. First of all, did everyone have a good time at the party last night? I'm impressed that you're here for an early morning session on cubes after that, so you've got my respect already. And so today, the topic obviously is getting the most out of multidimensional data sources. So they chose the clever little title, it's hip to be cube. But what we're going to be talking about today is looking at a fairly high level, how do we work with cubes in Tableau, and what are some tricks to get some of the best performance out of cubes, and mainly why do they work the way they do in Tableau. I've worked with quite a few different customers on actually getting the most out of their cube data, and there are definitely some best practices and things that we can do that really make working with cubes very smooth and natural in Tableau. And there are also things that we can run into that may be frustrating. So we're going to address some of those and some of the best ways to get around them. So before we begin, we'll just cover the agenda, what we're going to do today. So we'll talk about the focus of this session, and then just the relationship between Tableau and OLAP cube data. We'll explore some of the unique features of using cubes in Tableau. We'll touch a little bit on building calculated members with MDX. And I want to be clear up front, we're not really going to dive into how to use MDX for any given scenario. I think there could, you could write a book on that, several books maybe. So we're going to touch on that as more of a launching point, if that's something that's interesting to you. And then kind of come back up to the high level and just talk about the differences between ad hoc and OLAP analysis in Tableau. What are the features of both and what those are. And then wrap up by talking about the future of cubes and where we sort of see them now in the market and where they seem to be going. So, first of all, for all of you, why are we here? We're here because we have multidimensional data, so we have cubes in our organization, and we also have Tableau. But you may be relatively new to using the two together. If you're an expert on cubes, this session may be a little bit high level, but if you haven't really been using cubes in Tableau yet, this could offer some nice advice on really how to maximize the resources that you have. Why aren't we here? We're not going to be talking about really building cubes from scratch, and we're certainly going to touch on what it means to modify a cube and when that might be necessary, but we're not really going to dive too deeply into that today. So what you should take away from this session, oh, and also, sorry, like I mentioned, we're not going to be really diving into MDX, the query language for cubes today, although it's something that certainly is very useful to know if you are working with cubes. So the takeaway, what we should glean from today's session, that would be understanding really how to get the maximum efficiency from your cubes in Tableau and what you can do to avoid common frustrations and really just how to optimize that workflow. So first of all, what is a cube? Now, there may be several different ideas about what exactly that is, but fundamentally, cubes are a data structure that's designed to provide planned and straightforward access to data that is pre-aggregated. So that means we've taken values and aggregated them together. So we could take thousands, millions, billions even of rows of data and combine them into pre-computed values. Now when I say OLAP, what does that mean? So OLAP stands for Online Analytical Processing. And what that is it's a method of taking in data and being able to query it live, being able to ask questions and get answers right away. Now, cubes are built around that logic. They're built around us being able to take a question and get a response right away. And they're also built on a multi-dimensional data structure. That means that, as we see in our nice little picture here, we have different dimensions like source, route, and time, and then they gradually descend into hierarchies that get more granular. We have the first half of the year, second half of the year, different hemispheres, and routes. And that really slices up our data into portions that we can more easily analyze. And those values are already computed in the data. So that means when we're asking a question like what is the, what's our value for the first quarter in Africa by air, we're pulling that number and it's just one value. We're not hitting the thousands or millions of rows that may underlie that. So we can get responses very quickly without having to crunch a lot of data. And we can also then, because we can think of the cube as having these different dimensions, we can slice off different segments to get larger aggregates, like all of Africa, all ground transportation, or maybe a subset of that, all ground transportation in the fourth quarter. But all those numbers can come to us very quickly without having to query many, many different rows. Now, what is OLAP versus more traditional databases, or what we might think of as other database types? Well, OLAP is designed for really rapid query, and it comes from a time when we didn't have the compute power to really keep up with the volume of data that we were handling. So we can think of OLAP as really a bank account or an ATM, where we are able to enter a result or enter our query and return an answer. How much do we have in our bank? How much did we spend this month? Get information like that very quickly. Now, on the other hand, what cubes are not great for is writing very quickly. A traditional relational database, you can write individual rows, and those might get added very fast. And that could be considered an online transactional processing system, or OLTP, which is a little bit of a different logic. In OLTP, we are taking in transactional data as it's generated. And so that means we're optimized to write very quickly. We can, when a sale occurs or when an order is placed, that row is added to the database right away. So we can add data very fast, but those type of systems, what we might think of as a more traditional relational system, it takes a long time to read all of that data. So that's really where the fundamental difference between a cube and a relational data source is. The cubes are optimized for read. They're optimized to get us the answers very quickly. Other databases may be optimized to write and to accept data very quickly, but be much less accessible in terms of being able to find out answers from that data, which is why we're all here, to do analysis. So why do we build them? Well, this is kind of what I've been getting towards for the last couple minutes. Because we pre-compute those values, it means that cubes are very useful when we have more data than we can readily compute. And there's sort of, that was more prevalent in the 80s and 90s when, data started to become more and more of a living field. We were getting a lot more of it very quickly, but our compute power hadn't really caught up to that data. So that's when cubes were kind of in their prime. When organizations wanted to question their data and get answers, they could build a cube, and it would be the basis of a report, and that report could run daily, weekly, monthly, and it would always generate the same values, sales by day, orders by hour, something like that. And the cube was well suited for that because it had these predefined questions built into it, those predefined aggregations. Now, in the 90s and beyond, sort of in the last 10 or 15 years, obviously our computing power has gotten, our computers are much faster than they were 15 years ago. And so we were able to catch up to that data and actually make, in a lot of cases, relational databases that handle data at the row level workable for both adding transactional data and for query, for reading, and then for analysis. Now, something I'm going to touch on towards the end of the presentation is actually, again, we're starting to reach that inflection point where we have more data than we can reliably compute very quickly. And so there's actually a use case has opened up for cubes moving into the future, which I think is kind of exciting and interesting. But because we are bound by that predefined dimensional structure, the utility of a cube is strictly limited by the questions that were in mind when the builders designed it. So cubes can be fantastic for answering any number of different questions, like I was saying, orders, sales, volume, counts of users, all of those kinds of things, but they have to be built with that question in mind. And something else we'll talk about a little bit later, but where we frequently find frustration is when we try and use a cube to answer questions that were not built into it, that were not in the mind of the designers when it was being constructed. But for regular reports, cubes are a fantastic resource because they can get us our answers very, very quickly. And a little bit of trivia, and it sounds like some people in the audience may have known this already from talking to people before the session. Tableau actually has a very unique history of working with cubes. When, very early on in the company's history, when Hyperion owned Essbase, if anyone knows the Oracle Essbase cube platform, back when it was owned by Hyperion, Tableau was actually the OEM visual analytics solution for Hyperion Essbase, and that was one of the really big early boosts in the company's history. So it's almost fair to say that Tableau owes its continued growth and success to a cube, which I think is kind of funny. But cubes have really been a mainstay of business intelligence for as long as that's been a term, because they are so efficient at answering questions and allowing us to get around large volumes of data to get answers. So now, let's dive in a little bit and explore some of the actual unique features of using a cube in Tableau. So we've talked about the theory. Let's get a little bit closer to the practice. Now, this is a quote I like. A cube is an imitation of life, or maybe even an improvement on it, although I think Erno Rubik, the inventor of the Rubik's Cube, may be a little bit biased in that opinion. But the fundamental theory that really underlies everything in the interaction between Tableau and cube data sources is that Tableau respects the structure of the cube really in all ways. And what do I mean by that? Well, it's that Tableau will always respect and accept the way the cube was built. So the things that we may be used to in terms of on-the-fly metadata management, building hierarchies, creating groups, aliasing fields, even creating really complex calculated fields, that doesn't really logically sync up with a cube because we can't alter those fundamental structures because the entire basis of the data and the aggregation is built on those that exist in the cube already. So we can't create new hierarchies in a cube, we can't group fields together, and we can't really re-alias or use aggregate calculations for that reason, because that would run against the structure of the cube, and the data values that we might try and glean from that would start to lose their meaning. They wouldn't really make any sense at that point. That being said, there are certainly ways to accomplish those objectives using cubes, but that's where we start to get into things that require a little bit more work. So it is certainly possible, but there's a balance to be struck between a cube that's built for what we want, and certainly it's possible to modify cubes that already exist to change their function a little bit, and that may sometimes be the right solution, versus working in Tableau to achieve our objectives. So what do cubes actually look like in Tableau? Well, really fundamentally, not all that different. Here we see just some basic analysis. If you've played around in Tableau, you'll be familiar with Superstore, and this is a cube that we built based on the global Superstore data set, so just Superstore spread all around the world. And we see that in this analysis, it's really fundamentally looks almost like anything else in Tableau. But one of the first and actually really cool things we can do with cubes in Tableau is play around with the date structure to do some interesting stuff. So I'm going to actually jump out of my PowerPoint for a second and into Tableau Desktop. And so what we see here is a pretty basic view in Tableau. We're just looking at our profit for our global Superstore broken down by year and quarter. And here we're really playing within the bounds of the cube, right? I mean, we have the higher level year, and then it's broken down into quarter. And we have the flexibility in Tableau to really easily move through that dimension. We can drill quarter down to, I'm going to reconnect here. Drill quarter down to month. We have month number. We have the name of the month. We can drill back up, or even back up to year. But that's pretty standard Tableau fare, and I'm sure most of you are familiar with working with data in this way in Tableau. So what we can actually do is turn the date fields that we have in Tableau, in this case actually using a little MDX, and this is a pretty simple calculation, into a continuous date. And this allows us to use our really cool date slider features for filtering and give us a very fine-grained control over what we want to see. So here we're looking at the very raw, very low-level day values in our cube, and we can actually make this continuous. So that's kind of neat because we're really getting around the very highly structured dimensional view of the cube and making it a little bit smoother, making a dimension continuous. Now, how do we do that? I'm going to look at our calculated members here. And it's a pretty simple calculation. We've essentially taken each low-level value, the current member of the order date, and we've pulled that out into a continuous, a calculated dimension. A calculated measure. And so we've turned a dimension into a measure. And that's pretty neat. And that's some magic where Tableau is actually, and this sort of starts to run against the grain of what I said before, but now Tableau has actually gotten a little bit out of the laws of the cube. So it's like, if anyone's seen The Matrix, you can bend the rules. You can't break them entirely, but we can do some pretty neat stuff on top of a cube like this. And so what this then allows us to do is break up even further. So we could say, if I wanted to look at year here, could start to break this down. And I think we're seeing a little bit tight there, but we can now use both together. So this is a pretty cool and powerful feature, and it's really kind of gets to the power of Tableau to be able to change dimensional structures like that. So what's next? Filters are a thing that is a very useful tool in Tableau, and something that is, again, of course, very useful in working with cubes in Tableau, but something that works a little bit different. And it takes a little bit to maybe wrap your head around the difference between a relational filter in Tableau and a multidimensional or a cube filter in Tableau. So again, I'm going to jump in. And so here, we just have a basic filter on our view. We have sales broken down by product categories, and we have products on the filter shelf. But we notice right away that the filter dialog, when I've checked show filter, looks pretty different than what we're used to. We don't have those, multi-select. We don't have a single value dropdown. We actually have a hierarchy shown to us here. And that's because we can individually filter the different layers of the dimension separately or together. So normally if I had a filter on, say, product category, I might be able to filter out furniture or technology, and I can do those one at a time. But, and this is where it gets really interesting, and I'm actually just going to jump ahead here. This is what we call a ragged hierarchy. We see the same thing, but I can actually then access lower levels of the dimension at the same time. So instead of furniture, I might want to just look at chairs, bookcases, and furnishings, and I see those have actually appeared separately. And then if I were to uncheck furniture, we now see a drilled-in view of the category to subcategory on furniture and an affected total there, but we see the other high-level categories. So cube filters are a unique beast set apart from the normal relational filters in Tableau because we can do interesting things like this, and that's owed to the structure of the cube. So again, that's kind of an interesting feature that comes out of the way that the cube is architected. We can actually pull those discrete locations from the cube, the bookcases, chairs, and furnishings, and see them at the same time as another higher level field. And this is something that if you run home and try it with a SQL Server or a relational database, this view is very difficult to achieve in a relational source where we have separate filtering like this, but comes naturally to a cube. Now, one other feature of filtering here is creating slicers. What are slicers? Well, they're a chunk of the cube that we're actually slicing, appropriately enough, off, and that's when we're filtering on a dimension that's not actually in the view. And how can we tell this is happening? Well, we see that little sigma up by location on the filter shelf. And what that means is that we've actually taken a slice, in this case of product category and subcategory, and we've sliced it off the cube based on the location, based on where those sales occurred. So that will happen every time I place something on the filter shelf that's not on the view. So again, to replicate that, I could use market, and I'll just select APAC and Africa. And we see we have that sigma value, whereas if I'd filtered on product, like we did here, we don't see it. And that's because we're slicing off a dimension that's not really visualized on the view, but provides us with a powerful tool. We can take data by segment off of the cube. So it's, working with cubes is kind of interesting because it's sometimes helpful and sometimes unhelpful to try and visualize it as an actual literal three-dimensional cube, because sometimes that makes sense, but in the real world, most oftentimes, we don't just have 3 dimensions. We're dealing with many, many more, and so it becomes a little bit more abstract than just seeing a, an actual cube. But we can think of every value in a cube as a location in a coordinate system that can have between 1 and n dimensions. Yeah? Sure. Exactly. So in this case, actually, market is not a hierarchy. It's just a flat dimension. So that's why we don't see that hierarchical filter here. But for anything that is already hierarchical in the cube, that's when we'll see that cascading. So if I were to, for example, take market off here and place product, the hierarchy, on the view, now we start to see that hierarchical menu here, and we can drill in, drill out. I'll place it, and then we see that hierarchical filter. And it's actually, right now, it's accommodated for what I'm showing on the view, which is every subcategory. But then I can say I want to see office supplies as well. And now we see that as a separate full value for the entire aggregation of office supplies. And then below it, the individual breakout on subcategory. Yeah?
Functionally, though, that's not on the view. Functionally doing exactly the same thing. Other than, I'm not sure why this point of Tableau is.
So it's a little bit of a way, it's a different way that the actual calculation is performed on the back end of the cube. And so just to keep things moving along, we can sort of take the questions after. But yeah, so it's a good question. It's really how the function is actually performed under the hood and sort of what's happening on the cube when you're filtering what we're actually seeing, so the dimensions and the values that are right there on the view, versus something that's kind of a little bit more abstract and it's not actually on the view, but it is affecting the cube. Good question, though. It's great. So we've now kind of talked through, yeah. So tabular is a little bit different, and we can talk about that after as well. That's a good question, though. That's something we're starting to see more and more is people working with the tabular model. So if we have a second after, I can address those that as well. So now we've talked about filtering and dimensionality. Let's talk a little bit about calculated fields and how those are going to work. Well, basic aggregation calculations, like we think of sum, average, those won't really work in the cube or in Tableau off of the cube because we don't have the ability to change aggregations, because those aggregations are already predefined in the cube. They're totally baked in. So we can't modify those directly. Luckily, Tableau gives us table calculations that we can use to perform secondary aggregations on top of those predefined values. So while there are our normal tools to change aggregation won't work on the cube, table calculations will. And that means that we can do some really interesting stuff using, for example, year-over-year growth, running total, any of our table or quick table calculations to do secondary aggregations on top of the table that's visualized in the view when we're working with a cube. Now, on the other hand, level of detail expressions, where we're actually trying to set the dimensionality and change that in a targeted way, won't work, because that, again, that notion doesn't really exist on the cube of trying to reset dimensions or trying to find different levels of dimensionality, because everything is already baked in. So these are, again, areas where people sort of say, oh, it's difficult to work with cubes. You can't do basic aggregations. You can't do level of detail. But those, again, it all goes back to just respecting the fundamental structure. It's not something that is possible because it doesn't really logically make sense when you know the structure of the cube. On the other hand, also, sets are a good way of accomplishing grouping. We can use sets in Tableau to create groups of members of a dimension that we can then continue to explore. So let's take a quick look at some of these areas that we're talking about here. So on a calculated field, if I open up my field box, I see that trying to type something like sum doesn't work, but I am prompted with those table calculations. So, for example, if I wanted to look at, I'll bring out order date on the view here and look at sales. So now we see just a view of our sales over time. I can also go to a quick table calculation and maybe do something like running total. And so now I've done, with just a click, a really neat secondary aggregation. We've actually taken those values as they're being fed into Tableau and then locally done a new aggregation that didn't exist in the cube before. So this is a great way we can add value by performing those secondary calculations. We can even get a little bit more interesting and maybe do percent difference and compare essentially year-over-year growth. What's the change from the previous year? And this can all be done with a single click, and this is the real, I think it becomes more interesting and more exciting when we really understand why fundamentally this is so powerful, because we're actually modifying, in a sense, the data from the cube. Now, we can also, I'm going to actually clear that table calculation, create sets. And so say I wanted to just work with 2012 and 2013, I can create a set here and call this maybe first 2 years. And when I place that on the filter shelf, I see that I've just created essentially a group of those two dimensions. And if we're to drag year off the view, we now have an aggregate of the two. Now, sets work a little bit differently with a cube than they do in normal relational sources, because, for example, if we look at the filter here, I can select different members of the set, but I can't do the way we would think about it normally of filtering out values that are outside the set and values in the set. And that's just the way that sets are actually, again, designed to work on a cube. They can group together selections of a dimension, but I can't really say compare the everything outside to everything inside. But it does give us a powerful tool to create our own groupings of different parts of a dimension. So now we've covered some of the basic calculations, and I think the takeaway again here is that we can generate new aggregations. We can really get some added value. Just one sec. We can get added value, but we can't fundamentally really change or break the laws of the cube. And yes?
So with sets, is it possible to take, say if you have 5 members, is it possible to take a set of 2 and then a set of all of them and do calculations against each
That's a good question, actually. Let me get back to it next. I'm not actually sure right off the top of my head. So that's a good question, though. I will address that after. So we've now taken it through looking at some of the calculated fields here. So one of the other really neat things that we can do with a cube in Tableau is to use blending. And that, if you're not familiar with that term, that allows us to combine data from multiple different sources and aggregate data from the secondary source up to the level of the primary source. And this is done locally after we've queried both sources. Now, and here's a view of the blending pipeline. Cubes, again, because of the predefined nature of the aggregation, can only blend as a primary source. So we can use cubes as the source of our blends, as our first data source, but we can't use cubes as the secondary source. We can't try and, again, change the aggregation of the cube. So say we had just category on the cube, and we had a second data source with a subcategory. There's no way we'd be able to blend those two and try and change the level of the dimensionality, because it wouldn't work in the cube. That data essentially doesn't exist on the cube. It's only as aggregates. That being said, blends provide us with a really neat tool to sort of add some extensibility to our cubes in Tableau, because they allow us to bring in other data sources and use the two together. Say we have data in an Excel spreadsheet, and in a cube, we can create visualizations that combine both. So what does that look like? Well, fundamentally, it's not that different than a blending experience in another source. Here we can see I have a cube here, and I've actually, in this case, product category exists in both sources, so I've taken the sales value from the cube and broken it down by product category from another source. So we can see that secondary mark here, that little database cylinder with the orange check, which is telling us that that's a blended field. And so we're essentially creating a new aggregation. Now, that's kind of interesting, and I could also do the reverse. I could bring out product category from the cube and break down sales in the other data source. Yeah? No. So again, the rule being that cubes can only be a primary source, so you couldn't blend cubes together because that would be involving one cube as a secondary source in the blend. So yeah, that wouldn't work, unfortunately, because of the, and I think the use case, I could, I guess, imagine a situation where the cubes have the same level of aggregation, but then I would sort of wonder if that was the case, why they wouldn't just be in the same cube. And if they had different levels of aggregation, then they wouldn't sort of jive together like that. Great question. And I would say, I think pretty broadly, it would be better to bring the data into the cube. This provides us a resource when that's not possible. I think for the answer to pretty much every question today would be, if you could do it in the cube, that's the best way to do it, because then you're not having to kind of battle around the sort of eccentricities and the unique sort of limitations that come with working with a cube. So yeah, I think that's pretty much, if anyone has that same question, why not do it in the cube? I would say the answer is, if you can, do it in the cube. But there are, of course, other ways to accomplish things. And one of the really interesting use cases for blending is actually achieving what amounts to grouping in Tableau using the blend. So here, we're actually grouping to a field that doesn't exist in the cube using a blend. So I have a database that has my sales managers and their associate subcategories, and then I have the matching subcategories from the cube, so we're blending on subcategory, but then I can use manager from the other data source to actually break up the values in the cube and create a wholly new visualization that includes new dimensional data. So this is a pretty cool use case, because it means I can essentially, using the sort of magic of Tableau, add a new dimension to the cube. And this could work with something like an Excel spreadsheet. So if you wanted to blend on an Excel spreadsheet with the cube and create new groupings, this is a way to do it. And I think that's pretty neat because it really adds value, and we can kind of almost simulate adding values to the cube by using blending, or rather adding dimensions to the cube by using blending. So we've now covered blending, and I think this is one of the most interesting and coolest use cases for blending with the cube. So now let's get into a little bit of MDX. And if you're not familiar with the term, MDX stands for multi-dimensional expressions, and it's the language that we traditionally use to talk to cubes. Now, I know that we've had some questions about the tabular model, and I think that uses a different language. I think it might be DAX. But the MDX has really been the mainstay of working with cubes for at least several years, maybe a decade. And what is MDX? Well, if you're familiar with SQL, MDX, although it's structurally quite different, we can think of it as SQL for cubes. And it's the language that we use to talk to, build, and modify a cube. And it really, it's in the name, multi-dimensional expressions. It allows us to find and isolate different portions or different dimensions of the cube based on that sort of analogy that I gave earlier. We can imagine every data point on the cube as a point on a grid that has n dimensions, where n is the number of dimensions in the cube. So what goes into creating a calculated member? Well, we've already had a quick look at one before. So if I wanted to build a calculated member in Tableau, I would select the drop-down, and there's actually a new button that appears if we're working with a multi-dimensional source, and that's calculated members. And there actually aren't any built on this cube. It's the other one. And so, say I wanted to just create a new aggregation, aggregation of all years of sales, and sort of run that alongside our individual yearly sales by month. So I can see each year, and then I can get a sense of monthly trends over the entire data set. Well, I'm using MDX to do that. I'm essentially saying, in the order date hierarchy, isolate the field order date, and the attribute order date, and take all values. And that's the MDX calculation to aggregate all years. And what's actually happening, it's a new dimension, but it's not going to appear as a dimension as though we created a dimension in a traditional calculated field. It will actually only appear as a member of the order date dimensional hierarchy. So in this case, we are viewing, I'm sorry, actually I misspoke there. This is actually in product category. Same exact logic, but what's on the view. So we're looking at all categories together and each category separately. But we can see the logic holds. We're looking at the products hierarchy, all the product category attributes of that hierarchy, and we're grouping them all together in a single aggregation. And so when we look on the view, we see exactly that. We've placed product category, and it looks just like product category does normally. We've placed it onto color, and we've now broken out an all categories member where we can track all categories together, and we can also track each category separately. So this is how we can use MDX at a basic level to change aggregations and actually modify the cube, add value, or ask new questions. Now, it's not as seamless as really drag and drop or writing calculations in Tableau, but we do have that option. The answer here, though, is you do need to know MDX to move through these. There are quite a few scripts available online that are a great place to start learning, but it is a process that does require you to at least know the script that you want to execute and potentially modify it for the fields in your cube before you dive in. But this is how we can do that. And then we can go in a little bit further and actually start doing some more interesting things. We can, in MDX, create a moving average. This is something we can also explore doing with table calculations. But here we go. We see just normal sales by day on the view. And then we also have this field lag4. And that's a calculated measure rather than a calculated dimension. And those actually do appear as fields that I can drag and drop separately onto the view. But if we view the MDX for that calculation, we actually have it up right here. We can see that we're actually doing aggregate calculations in the code. So we're creating an average of the range of values between the current member of the date hierarchy, so the lowest level value that's on the view, with using the lag function, in this case lag4, so lag back 4 values, between that and the current member. So for each point, lag back 4, find the range between those two, and then we see it's all wrapped in an average. So here we can actually, in the MDX, we can do custom changes in aggregation. And that's what the code for that function looks like. And we see it here on the view. It's a moving average over the last 4 days of sales volume. So this is kind of an introduction, and if it's something that's interesting to you, there are a huge range of possibilities what can be accomplished with MDX. But it's something that has to be done by somebody who is comfortable or at least has the knowledge to plug in an MDX statement. So then again, we get back to the point of if that's something you want from the cube, it might make more sense to actually build that in, because then that will be available really freely to everyone who uses it rather than requiring the user to be able to input that themselves. So there's a balance because I think most people actually may not know MDX, so that is the trade-off in those areas. And we can also, as we're sort of wrapping up towards time here, get to using MDX with Tableau parameters. So at the end here, we have a value all years, and we're going to actually fit the height here. I can drag this out a bit. And then we have this value date member. And what that is it's a rolling value that's written in MDX to look back over what's on the view, but it's powered by Tableau parameters. So I can actually manually change the MDX code using parameter input from Tableau. So I can look back over years, and I'm looking back currently 4 years, and we see that value jump or decrease. And I'm actually playing with that using parameters, and if we jump into the code, we see that I'm actually aggregating, again, a tail of range parameter 1 and, this is setting the range back, so the number of periods to look back, and parameter 1 is setting the period. How are we actually going back? And we'll notice, of course, that the parameters that I have on the view have different names than they're recognized here. And this is a little bit of a quirk of working with parameters in Tableau using MDX. Because the way the parameters are passed to the cube, it's actually at a deeper level than the custom names that I give the parameters in desktop. So I actually have to know the orders that the parameters were created. The way to do this, or to find it out yourself, is to actually, if you have a TWB, an unpackaged workbook, you can actually open it up and look at find the parameters in the TWB code if you're confused about the names. So that's a little bit of a trick, but you can insert the parameters and then use that to modify MDX on the fly. So it's a potentially very powerful tool for giving your users the ability to manipulate an MDX function and change that on the fly or build that into a dashboard. And so this actually sort of touches on my final point here. we have a view here that contains years and then an aggregation of all years, which is actually that MDX I showed you earlier, and then a changeable field on the view. So this is what we call a ragged hierarchy. An asymmetric view, not a ragged hierarchy. We talked about those earlier. An asymmetric view where we're actually not limited by the traditional kind of very locked-in sort of hierarchies that we would see, typically in Tableau, where we go, year to quarter to month and down, and you wouldn't really have anything else. Using cubes, we can create asymmetric reports. So views like this, where using calculated members, we're actually seeing different types of values on the same view in the same hierarchy. And again, a similar view here, where we're seeing an MDX calculation for sales, for last year's sales, and then at the end, all sales, and it's all on the same view, even though those aren't strictly fitting into a kind of cascading hierarchy like we would be used to. And the calculation for last year's sales just looks like this. It's, again, just a lag function, and it says for each point each year, look back one, and we'll find the previous value. So that's taken us pretty well through the functional aspects of working with cubes. We've talked about calculated members. We've looked at the code here, and this will be available to you after the presentation if this code is interesting to you. This is, again, where we're using the parameter to define the type of value that we want to look back, whether it's quarter, year, month, as well as how many back we want to actually go. And we've looked at asymmetric reports. So really, fundamentally, working with MDX in Tableau is about understanding that we can bend the rules, we can modify things a little bit, we can create new members of dimensions, we can pull members from multiple dimensions, so we can create very interesting combined query calculations that are sort of pulling in different attributes across dimensions. But we fundamentally can't modify the underlying structure of the cube from Tableau. I mean, that fits with our sort of general philosophy. Tableau is a read-only application. But that also gets to sort of the philosophy of working with cubes. You can only modify what you've got. You can't break the rules and really fundamentally change everything. And also, I think most importantly, you can't use calculated members or the other tools really that we've talked about today to fix a cube that's designed suboptimally for what you're trying to achieve. As a bottom line, to be successful with cubes, you need to have a cube that's engineered from its fundamental structure to answer the question that you want to answer. And I think that covers the takeaway. So MDX in Tableau is primarily a workaround, but it can be a very powerful one, and it can give us features that we are looking for. It can add value to the cube. Now, to take it back up to a little bit of a high level as we wrap up, exploring data in cubes is really, getting back to the origins of cubes. They're built using very well-defined rules, and they're great for answering very well-defined questions. So if it's a regular question that we're going to ask again and again, and we know it very well, cubes are going to be very powerful for that. Now, on the other hand, if we're generating new questions on the fly, which is where Tableau really sings, asking a question, getting an answer, generating a new question, that kind of on-the-fly analysis can be more challenging in cubes if the new questions that you've created don't really fit into the structure of the cube as it exists. So thinking about a business need or the business goals with cubes, it is very possible to get the most out of the cube as it's built using Tableau. There are a lot of great features. We've covered using calculated members, but also the easier stuff, using table calculations to do secondary aggregations, working with some of the, or very simple MDX to create continuous dates, blending to get new views. But there is still the fundamental rule that cubes are cubes, and Tableau can't change how the cube is built. And very briefly to touch on before we wrap up, the future of cubes. I've, even in the time that I've been working in in the analytics industry and in business intelligence, I've seen the reports of the death of cubes, and I've also seen plenty of counter reports that the death of cubes is greatly exaggerated. And I actually definitely would count myself in the second category, that we will continue to see cubes in the space for the foreseeable future as the data needs that we have continue to grow, and as we're working in the Internet of Things and generating more and more data. I think there's some statistic like we're generating more data every 3 days than all of humanity did up until 2005. I may be getting the exact numbers wrong, but in that spirit. And when we have that growing volume of data, we're going to need ways to ask questions of it very quickly. And cubes are fantastic at that. That's what they're built to do. So even if we have billions of rows of data at petabyte scale in Hadoop, we can use cubes to get value and business information that we need out of that data. And I just have an example here. This is actually a vendor that I have worked with before called Kaivos Insights, and their product is actually a cube built on top of Hadoop to allow people with huge volumes of data to analyze it in Tableau. So there are certainly new vendors out there. There's AtScale is another one. I know they're here at conference, and they build cube-like structures to get analytics on top of massive, big data. And again, gets back to the spirit. We're at that inflection point where data has exceeded compute power, potentially for the moment, and when we need well-defined questions answered, cubes really excel at that. And again, in this presentation, we'll have some additional resources. One thing we didn't cover was taking cubes offline. That can be done right now with analysis services using Power Pivot. You can create a .cub file, which is an offline cube, and that's actually what we used in the presentation here. And you can also extract cubes from SAP Business Warehouse. So that can actually be done with a Tableau extract. We are continuing to work on cubes. I've actually met with our development team that is working on cubes, so we can expect some new features in the next year or so. I can't obviously talk really specifically about that, but we are continuing to do work on improving the experience for users working with cubes. And here are some links to specific resources that really talk about how best to explore. One thing that does come up, and if this is a question that people have, for the tabular model for analysis services, I've definitely seen that more and more in the space. It is something that we can connect to in Tableau. I've worked with it. I've seen people do it. It is currently not officially supported, so there may be some quirks with that versus working with traditional MDX on analysis services as we would traditionally think about it. And so that's something that you can take up, with Tableau with support as it, or you're, if you're working with pre-sales people like me, as it comes up. I think that pretty much covers everything. So I think we'll wrap up, and we maybe have a few minutes here for questions. So thank you very much. Okay. Oh, and also, sorry, one more thing. Please remember to review the session. If you have any feedback, pro or con, we'd love to hear it. That's how we make these better and more useful for you every year. So have a great rest of your conference, and thank you very much. Yeah.
Yeah, we had a couple questions that people asked during the session. Do we want to handle those first?
Sure. Yeah.
He passed. Was there another one over here? Was that?
Hello.
Hi.
What about the cubes for SAP Business Warehouse? How can I extract this information?
So I think the best way to handle that would be to get the resources online. So it can definitely be done, SAP BW. It can be done. It takes a little bit of special work, more than a normal extract. If you give me your information, I can make sure that you get the instructions for how to do that. So yeah, if you have a business card or something, I can take that.
Anyone have a question?
Sure, and can you remind me more, or just repeat it?
Sure. So the question is that, say I have a group called technicians and they have different types inside that group. Can I take total work done by a subset of them as a set and then divide it by total work done by all technicians to come up with some type of work mix?
That's a great question, and like I said, don't know, so I'm going to just check how that would work right now. So we can't do calculations on top of sets, it's looking like. And if I created, let's see, I'm just going to really quickly build another one here. Oh, we got a little bit of a typo. My hunch would be not, because, yeah, so what's going to happen is because when we're working with those two sets together, it's automatically going to filter to the rest, which is what we're seeing here. Putting two together that have separate members will just essentially filter each other out. So we're not going to be able to do calculations like that using sets, so using that grouping, I think would be the answer.
So then, and
As a follow-up, then would I be able to take one set and do a percent of total?
That is a good question. I think just from time's sake, do you have a business card or something that I could take? Or?
but I can give you my name.
Perfect, yeah. I think being able to follow up would be really helpful for that, so, yeah.
Any other questions?
So I just wondering, as like a new development,
Mm-hmm.
would you recommend to create a new multidimensional model?
I think that really depends on the business need. In terms of usually building new databases on your side,
Right, instead of create a new Tableau model or not at all, just to create a new Tableau data source.
I personally would recommend, without knowing really the specifics, if you can build it as a functional, if you can build it as a Tableau data source, I think that would be fantastic. And obviously we can do metadata management in there that actually starts to look a little bit like a cube, building hierarchies, creating those fields on the fly. So if that can be done, and that's that answers your business question, then I think that will be the easiest. The primary reason would be that you can iterate on that very quickly, so the development time will be a lot less than building a new cube. I could definitely see it, depending on the scale and depending on how you need it. Tableau extracts definitely aren't a replacement for a full-scale data warehouse. So depending on the size, the scale, and the usage, it does maybe make sense to build a new data warehouse on a cube. I think it's also, if possible, to explore using a relational source versus a because if you build a relational data warehouse and then build Tableau extracts or Tableau data sources on top of that, that can be a way to have all of your data in one place and then manage it and distribute it in a curated way. So I think that's definitely an interesting possibility. But I think bottom line, it depends on the specifics, and there are use cases for cubes even still. Yeah, I think yes, I think it does, and I think that we were definitely seeing other organizations doing net new cube projects, so that's very true. I think just it's something to consider because there are other options now to just balance the benefits versus the the development time and the upkeep that has to go into making the cube continue to be valuable. I would weigh that in that decision, and I think exploring the alternatives can be really valuable. But that being said, there are definitely people still building cubes. Cubes are definitely still useful for the things that I've outlined. So that's absolutely still possible.
So my question is,
Here,
I saw
do you
that
wanna
you
just-
on the last slide, what you did was took the cube offline.
Mhm.
What are the benefits to that, and can you deploy the offline cubes to Tableau server instead of doing a live connection into
Yeah.
the database?
The benefits are you can be off the internet and continue to explore. It's not I would say it's not a replacement for a cube data source that's a live connection because it's not going to update. Once we've pulled it down, it's static, and it's not like an extract where we can run a refresh. So I would say it's a tool. It's not a replacement for a live connection to a cube. Yeah, but say you need to, you're on a trip, you might not have Wi-Fi or something like that. Then it can be a good answer in that case. Thank you. Yes, absolutely. And so it will be in the PowerPoint presentation, which will be available to you. It will. You can Google it online. I think I have the link in there though. So I think that would be the best way. But if you Google just taking a cube offline, it can be done through Power Pivot in Excel. Exactly. So you connect in Excel and then choose the dimensions and measures that you want to bring in, and then it will create an offline cube. Can you bring the entire cube down? Yeah, I think so. I think you can. Yeah, absolutely. Thank you very much. All right, and I have to dash off. So for everyone else who's still here, thank you very much, and please have a great rest of your day.
Cool. Thanks, everyone.